are back to part 2 of this particular video and on examples of vectors and scalars. We'll stop at number 8, and I also say don't forget that most of the quantity examples are listed in part 1 of chapter 2. So go and watch the video. Now number 8 say the pair of physical quantity consisting of vector only are A, acceleration and speed, B, vector only, acceleration and speed, B, displacement and torque. And that should be the answer B. Let's see other example. C, velocity and distance. Distance is a scalar, velocity vector. Option A, acceleration is a vector, speed is a scalar. D says momentum and power. Power is a scalar, as momentum is a vector. So the only correct options there is B, displacement and torque. Number 9, it says which of the following, that is 2008, number 4. It says which of the following is not a vector quantity? A, altitude. Altitude is not a vector quantity. That is very sure. B, acceleration. C, displacement. And D, weight. So the answer is altitude, option A, which is number 9. Number 10, it said the pair of physical quantity that are scalar only are dash. Volume, area, volume and area, then moment and momentum, C, length and displacement, D, impulse and time. So the answer to that question that are scalar only is volume and area, which is option A. So option A is the correct answer. So take note of that. Number 11, we said what? That is the last. Number 10 is 2013. Number 4, jam. This one said what? A quantity which require magnitude and direction to be specified. That is the definition of vector quantity. Take note of that. A is dash. A, distance. B, displacement. C, mass. D, temperature. Displacement, mass, and temperature are all scalar. The only correct option there is option B, which is what? Displacement. Option B. Number 12, he said what? Electric potential, Roman figure 1. I think this question will be answered very similar to our question we solved in number 4, 1988, number 5. Go and check the question. It's the same thing. So let me, will not waste time there. He said what? Number 12. The electric potential, Roman figure 1, Roman figure 2, torque, Roman figure 3, kinetic energy, Roman figure 4, momentum. Which of the quantity listed above are scalar? If electric potential, which are all potential, are scalar, so that one is out. Torque, Roman figure 2, yes, correct. Kinetic energy, scalar, no. Momentum, so that should be 2 and 4. So option A, 1 and 2, B, 1 and 3, C, 2 and 3, D, 2 and 4. That is answer D. Now, number 13 says when vectors are added, when vector plus vector will give us vector. Then scalar plus scalar quantity will give us what? Scalar. Please take note of that. Then scalar multiplied by vector will give us what? Vector. Don't forget multiplication that we are talking about here. We have two types of multiplication. We have the cross product and the dot product, because we can have it like this: scalar dot vector. In mathematics, specifically for that mass, we have dot is scalar quantity multiplication, while this one is what? Vector multiplication. So that means what? Scalar what multiplied by vector, we are going to have what? A vector quantity. Then scalar multiplied by vector, this is vector, sorry, we have what? Vector. So in that case now, please take note of that. Basically, so in this case now, they ask of what? Number 13, when vectors are added, the result is dash. Yes, the result is what? Vector. Then take note of that. When you take magnitude of vector, magnitude, if you take magnitude of the vector quantity, all you have is what? Scalar. Magnitude is what? This sign is absolute. It means magnitude of that vector. When you take magnitude, you have vector. You have a scalar. So the option, when vectors are, number 13, when vectors are added, the result is dash. A, scalar. B, scalars and zero vector. No. C, vectors and scalar. No. D, vector. Yes, that is the answer. Option D. 2008, 18, number 6. This question is not common. You say number 14 now. You say which of the following is a vector? A, energy. Energy is a scalar. B, temperature. Temperature is a scalar. C, viscosity or velocity rather. C. Yes, correct. Then D, volume. Yes. Volume is a scalar while velocity is a vector. So the answer is C. That is number 14. Let's go to number 15. You say what? Which of these following quantity is a vector? This is Waec question now. We've started with Waec now. A, speed. B, distance. C, energy. And D, momentum. Momentum is the answer. Waec 2006 rather. Number 11. Then number 16. You say which of the following is not a vector quantity? A, momentum. B, force. C, velocity. And D, temperature. The answer is temperature. Temperature is not a vector quantity. Number 17. Which of the following pair of physical quantity is made up of vector? A, speed and displacement. Speed is wrong there. Vector only. Yeah, B said mass and force. Mass is not a vector. C, displacement and acceleration. Yes, correct. D, moment and length. Length is a scalar, it's not a vector. So that answer is displacement and acceleration. Option C. That is Waec 2014, number 7. Number 18, I say which of these following pairs of physical quantity comprises vectors? A, capacitors and inductance. Both of them are scalar. Force ratio and velocity ratio, they are all scalars. Force ratio is also called velocity ratio. Why? Well, it's called what? Mechanical advantage. Why? Velocity ratio can also be called the distance ratio. So, which is what? The effort arm over the what? The load arm, which is effort, distance by effort over distance by load. So that one is what? C says what? Friction and momentum. Yes, friction is a force, momentum is a vector. So that's the answer. So option C is correct. If you check option D, now I say electric field potential scalar and electric field intensity vector. So one is wrong. Number 19, you say which of the following is a scalar quantity? Tension is a vector, is a weight. B, weight, correct, is a vector. C, impulse is a vector. D, distance is a scalar. So that one, D's answer. That is 1994, number 1, Waec question. Number 20, you say which of the following is a scalar quantity? A, momentum. B, acceleration. C, displacement. And D, distance. Distance is the only scalar quantity there. 21. Say each of these following physical quantity is classified as vector or scalar. Which of the classification is correct? Now they put what? Electric potential. Electric potential is what? Is a what? It should be what? Scalar. They put, I want to classify my own first. The momentum is a vector. Then which one again? Gravitational constant. Oh, lovely. Gravitational field rather. Field what? Intensity is a what? A vector. Vector. So now we now want to look at the last one is magnetic what? Flux density. This one is a what? A what? Vector. Because of what? Is a magnetic field in that. Ordinary magnetic flux is what? This a scalar, but magnetic flux density is a vector. So gravitational field intensity is a vector. Let's see the one that is not well classified. A says electric potential vector, no. B says what? Momentum scalar, very wrong. C says what? Gravitational field intensity scalar, wrong. And D says what? Magnetic flux density. Magnetic flux density scalar, no. Gravitational field intensity. Gravitational field intensity. If I say electric potential is vector, magnetic momentum is scalar, wrong. C says gravitational field intensity. That one is scalar. Magnetic field what? Flux density vector. If I want to go for the answer there, I will say gravitational field intensity is a vector. But if at all you want to go for any answer, the one that is what very wrong is C. You understand? Like for exam purpose. But for me, I will classify gravitational field intensity. Because of the intensity here, probably might change it to scalar. So that is just that. So go for C. So for this particular exam, but that is my own this in there. Then, which of the following quantity is a vector? That is number 22. It says A, volume, B, magnetic momentum, C, energy, and D, speed. So which of the following is a vector? Volume is what? A, which is now is a scalar. Momentum is a vector. Energy is a scalar. Speed is a scalar. So the answer is what? Momentum. The last one, which is 23, I will give it as an assignment. Say which of the following set of quantity are members which are all vector. Which are all vector. Pressure, energy, and force. B is a force, displacement, and momentum. C says distance, acceleration, and work. And D says density, volume, and weight. These are options for 2021. Why question number 47. Now, the question I will ask you now is that you two also go and make your research. What is what? This one, classify this one. Gravitational what? Field what? Intensity. Gravitational field intensity is E equal to F over M. E equal to F over M, which is supposed to be what? Vectors. But in the options now, they are putting scalars. If you check that, for example, 21. So if magnetic flux density is a vector, no doubt. That one is clear. Electric potential of that 21 is what? Is scalar. They put vector there. The momentum is purely vector. They put scalar. So the only option that are because of this intensity that might change, maybe they are talking about the magnitude there. So you can go for the word. For this one, because they have magnitude and direction. Most of the times when we use intensity, they always classify them as scalar. So that is just that. So you can take a, so but you can still do your research about it and tell me your answer. Then gravitational constant is another one I want you to make research about. Is this scalar or vector? Gravitational constant. Please take note of that. Make research about that. What about what? EMF, electromotive force. Is it a scalar or vector? Classify them and type your answer in the comment section for me, because I'm done with this chapter. When we come next class, it's calculation we are going to talk about. So classify this one for me. Then classify what? Force what? Energy density. Energy density. Is it a scalar? These are the 4 examples. Are they scalars or vector? Classify them for me so that we can have a very nice time. Thank you. God bless you.